know, I no longer work at Cisco. I retired in December. I tried to retire, I failed, and now I work for a company called lispers.net, which is a one-man company, which is just me. So, and my mission in life is to get Lisp all over the planet, okay? So it's very simple. Just do it, right? So what I would like to talk about is what was Lisp, how it started off, what the original requirements were, and what the solution space we focused on, what it is today, and what at least I think it's going to be in the future. So Lisp in 2007 was a solution to reduce the size of the core routing tables. And I think it's done. We proved it in this Lisp pilot network where hundreds of routers, more like 300 routers, are in 30 countries deployed, pretty much across the world. And a lot of people in this room participate in this. And if we want to continue that participation, a special call out to Daryl and the team at Cisco for managing it in their part-time while they do detailed design and development and products and everything. That we've learned a lot from that. You know, guys like Luigi and Damien were on it day one. I mean, awesome contributors to the protocol and to everything. So that is live and well, and we proved that we can multi-home by using this pilot network. We proved that we didn't need any cooperation by anybody in between the Lispers that we're testing on the network. That just shows that the underlying network didn't have to carry these EID routes. Okay. So we also proved that the solution could be purely network-based. So what we did is we decided at the very beginning that Lisp would run in routers and network devices. But we're starting to learn that it has a possibility of running in end systems. Now how pervasive we want that to be remains to be seen, but we think it's pretty compelling to run it in a multi-homed little device called a cell phone because there's many radios on it and you may want to use all radios. So we see that maybe the solution could move to host-type computers, even though, you know, even things like wearable systems as well. But more on that later. The solution to make multi-homing easier, I think it's done as well. A lot of, there's hundreds of examples from enterprise network deployment to residential multi-homing to statewide education networks, as well as to the Lisp mobile node devices that can do multi-homing. These were the original problem sets that we set out for in 2006. 2006, there was an IB workshop on routing, and that's when we tried to solve these two problems, and that's what Lisp was for originally. So from 2007 until 2009, we were in the IRTF and did a lot of research. That's when Luigi and Damien came and helped quite a bit. But in 2009, that's when the IRTF effort transitioned into the IETF working group. And that's when we began open protocol development and had an open process. No vendor has any intellectual property on Lisp. It's very important that it remains open. And then the Lisp pilot network became 2 years old in 2009. So you can see it's been running for quite a long time. And it's had its greatest expansion in that year. From 2010 and 2012, what we saw is Lisp products came to market. Open source projects had full Lisp feature sets. Lisp Mob, Open Lisp, these were protocols that were done by the university community and now are very feature-rich and are being used for new things like putting stuff into OVS, having more advanced features, and so this has been great work. And then we're also seeing that the network spend now is for Lisp hardware and software. Before people had routers and said, oh, I have these existing routers, let me try this Lisp stuff. Now what they're saying is, I want to buy this hardware because I want to run Lisp. So it kind of reversed the motivation, which is good, because now there's a revenue source because of Lisp, not the other way around. So no, people are no longer just piloting Lisp, they're actually using it in production environments. This is great progress. So today, or 2013, the middle of 2013, we have our RFC status indicates a stability level. We have 7 RFCs, experimental RFCs, that were published in January of this year. And now we can differentiate with confidence what part of the protocol design is production level, what part of the protocol design is work in progress, and what part of the protocol design is going to be advanced research. And we're all over that because we're trying to decide how to bring it from this step to this step to this step very carefully in a coordinated effort. So in production in 2013, it's basically the RFCs, these 7 RFCs can support roughly these sort of use cases. And these are the use cases that are popular. Obviously, saving the routing tables and doing multi-protocol multi-homing, meaning IPv4 and IPv6 could run over IPv4 or IPv6, either dual stack or homogeneous on each end of the namespace. And low OpEx managing, addressing, and core routing is going to happen because now DNS names always latch to these static things called EIDs. You don't have address management problems anymore. And so we're seeing a lot of enterprises like that idea. And there's rapid VPN provisioning because when a VPN site pops up, it's just like an EID popping up and you register the mapping database where you currently are. And data center mobility is the most popular in terms of revenue in the data center, and device mobility is the lisp mobile node, which still is in its infancy in terms of deployment. So the work in progress group, the work that's happening, that's going to happen this year and after 2013, are basically all the internet drafts that are working group documents. Notice it says draft IETF. These are all that are in charter right now. And we see that the deployment draft and the mid-draft are the furthest along. They're in working group last call, and then these other documents are worked on. And what we've put a concerted effort together to make sure that we work on all this and get this stuff published in stable before the next IETF, so we can meet the next IETF. And the research work are basically all the individual contributions. There's many that aren't listed here that have timed out or have not been submitted by the deadline, but there's 3 or 4 more that can be added to this list. But these are the sorts of things that we're working on, really important things. And these are some of the use cases we could talk about today. Doing terrible on time. So the future of Lisp. We find that new use cases continue to spring into existence. And the reason is because a level of indirection really helps a lot. By putting this level of indirection at the routing layer, we're able to do all sorts of mobility things. And I'll show you the high-level use cases and the low-level infrastructure use cases that spring from this level of indirection. I've talked to many early startups and VCs, and they see a network change going on, a huge change and a huge opportunity for new types of devices to be put into network, new types of functions. Okay. Incumbents are seeing openness of the Lisp community and the technology and want to jump on it. We see many cases of that. So the use cases. These are the future use cases that I think will continue to move. Overlays will provide ubiquitous IPv4 and IPv6 multicast. If you already have an overlay and you want to run multicast, you want to do IPTV services, you want to do financial and market data distribution, and you don't have your EIDs injected into the core, which you don't want to, you have to get multicast to work. So there's a lot of, this is in the advanced research stage. We have the basic multicast stuff working. The Lisp multicast RFC is at almost the production level deployment stage because we have implementations of it. But some of the ideas of doing traffic engineering with it and trying to avoid head-end replication, those things is work in progress. How about network functions, virtualizations, and service provider data centers? This is a whole new area getting very popular. It's looking again at how flow switching or flow caching or flow routing, whatever you want to call it, can be done. Can we do this with an overlay model? And guys like Sharon have proven with Context Stream that this is very desirable. And he's using Lisp because it's open. Very important. Lisp will make SDN controllers scale better. Rather than having SDN controllers program fibs, because there's a lot of fibs out there, maybe it should program this data structure in the network called the mapping database. And let's have protocols pull information from the mapping database and cache it. So maybe a combination of controllers and protocols, that hybrid approach, will be the best of all worlds. And then people can build applications and have programmability using some of the ideas that the SDN crowd is publishing. Tons of policy and security use cases. We can go back to now doing access control in IP networks by doing it at the control plane. If you don't have a locator, you can't send packets to somebody. If you have a locator and you're encapsulating packets to somebody and they think you're DOS attacking you, they can say that they've moved and give you no locators in return. And that means the DOS attack's pushed all the way back to the source. This is a good thing. So all the policy now can be managed from this centralized view called this mapping database, a data structure that's distributed, but a centralized view that's in the middle of the network. Wearable devices on your body can have EIDs, right? I can have an iWatch, I can have a Fitbit, I can have my Nike shoes. They can all be signed EIDs. And of course, since they are not really on the network, they use low energy Bluetooth, who's going to be the locator for them? Obviously, the hub is going to be the mobile phone. That's going to be our loc for all those devices. So if Daryl wants to wear 100 devices on his body, we do not have to put 100 entries into the map cache or the mapping database. Because guess what? As he roams around, all those 100 EIDs will share the locator no matter where he goes. So we have an aggregatability opportunity here where we can make it scale. So that's going to be very interesting as time goes on. Now, I don't know if my Fitbit is going to have to talk to Daryl's Fitbit. I mean, it'd be nice to have some peer-to-peer communication going on and rather always going to the server, but we'll see, right? Tracking things. We want to track pets, their location. We want to be able to talk to the pets using IP addresses. Maybe this needs to be done at the network layer, not the application layer. One has to ask that question. Maybe you want to track merchandise. So we know merchandise comes off a shelf because the shelf is a particular locator and the shopping cart is another locator. Now what we can do is the retail store can find out everything that Daryl's buying and then check him out whenever he says, "I'd like to leave, please." Things like that. Spectators at sporting events, you can find out where they are and you can spot discount bonus them. So you say, "Hey, you're over there in right field. Maybe if you go to that beer stand over there, I'll give you 10% discount. I want to send you over there because the lines are shorter and you can get back in your seat and watch the game." Okay. And sensors. Sensors will be all over. I don't know if it's a good or bad thing, but sensors are going to be all over. They need to be addressable. We can make hybrid clouds work together because right now they're all vertical. You cannot move a VM from Rackspace to Amazon. And we know a lot of people are going to want to put middleware there to make that happen, and they want it to be mobile. Lisp will be the solution for them to do that. Everything will be mobile. Anything should be able to move around. Some things you don't want to move around. You want to give an EID to the Mona Lisa because if the locator is not the Louvre, somebody stole her. That's a good feature. And the Internet of Everything, whatever that means. I don't know if I want my picture frame on the wall to talk to me or Mona Lisa to talk to me, but the connectivity is there. EID assignment at birth. Dave Evans, the futurist of Cisco, said there's going to be 52, whatever that number is, addresses per person. So I guess we're going to be able to address every molecule in our body. Is this useful? Who knows? But we need addresses. And of course, this little baby's going to grow up and move around. We know that baby has an ID. It has a name, right? All of us have names. So our names are used all the time. And by the way, our names, when I go out to dinner with Daryl socially, I call him Daryl. When I work with him, I call him Daryl. Why do we have to have different addresses if we're at work versus when we're doing things socially? So same thing with IP addresses. So Cisco says there's a $14 trillion, that's T as in trillion, total addressable market for the future. And the claims are that connectivity to the house will go up 64 times by 2023. That Wi-Fi speeds will go 16x by 2023. And that the compute power is going to go up 32x. And the number of things that are going to be addressable are going to go from 10 billion to 50 billion in 2023. And miniaturization will still continue to happen. Okay? So, this is what, well, of course, networking vendors are hoping this because it means more bandwidth, more gear. But could you imagine having a video stream always on? We don't have to really do calls anymore. If you're on Instant Messenger or you have a walkie-talkie sort of thing, you don't assume you have to make a connection. Well, people are going to have these huge displays on their walls, and the video is always going to be on. And so when your grandmother or your parents walk into the room, you can have dinner with them. There should be no reason why you have to make a call. So there's going to be a lot of idle video being sent over the network. Everything's going to move and everything has to be addressed. If everything has to be addressed, you need IDs to identify what you want to talk to. And those things will move around. This is why you need locator ID separation. But what's needed most important is we need a ubiquitous, production-level, multi-organizational mapping database system. We have to start there. And we need it to be neutral, we need it to be public, where user networks can depend on the Lisp infrastructure. So when they connect to the network, they can assume, does anybody ever say, is there a DNS server out there I can use? No. They assume that they're going to be configured with a DNS server address, and there's some infrastructure out there that's going to allow them to do name-to-address translation. They have to have the same assumption here with the IDs. Apple Computer said, if we go ahead and put Lisp on iPhone today, who do we point to out there so we can do this translation? And I said, well, we're working on that. And they go, well, can we do it in iTunes? I go, yes, you could. But then again, it's going to be a private mapping database system. Are private mapping database systems good? Yes, they are. But we need a global one as well. Okay? Somebody has to do a global one. And it's this community that's an open community will do it. So that's the end of the presentation.